Hello everyone, today is day 16 of solving a LeetCode problem every day. So today I'm going to solve evaluate reverse Polish notation. So I already went ahead and solved this problem, but I'm just going to go over my solution really quickly. So you were given an array of strings tokens that represent an arithmetic expression in a reverse Polish notation. Evaluate the expression, return an integer that represents the value of the expression. So first of all, in case you don't know what reverse Polish notation is, it just means postfix. I didn't really know what it meant either till I searched it up. But for example, here we have 2, 1 plus 3 and times. So you have 2 and 1 and plus. So this evaluates out to be 2 plus 1, and then you have the 3 times. So pretty much you evaluate this and then multiply it by 3, as you can see here. So pretty much the operands always are going to come after the numbers. So for example, here in this case, you have a division operator over here. So you have 13 divided by 5, and then you add the outcome of that by 4, which comes out to 6. So the valid operators are plus, minus, multiplication, and division. Each operand may be an integer or another expression. The division between two integers always truncates down towards 0. There will not be any division by 0. The input represents a valid arithmetic expression in a reverse Polish notation. And the answer in all intermediate calculations can be represented in a 32-bit integer. So these are just some notes that are going to help us out. So in the question, first of all, it says that we are given an array that's going to represent an arithmetic expression in reverse Polish notation. So I'm going to assume that we aren't going to be given any invalid arrays. And second of all, it tells us over here the only operations that we need to account for. And then it also tells us here that division between two integers always truncates down towards 0. So I think these were the most important points. Let's see. Yeah, so I mean, anyways, this is how I solved this problem. Started out by initializing a stack, and then we pretty much have 5 conditions. So we know the token either has to be an operator or it can be an integer. So we have all these cases for if it's a plus, division, multiplication, or subtraction operand. Otherwise, what we want to do is just append the value to the stack that we initialize over here. Cool. So if the current token is a plus, what we want to do is pop the last 2 values off the stack and then append the addition of those 2 values. Likewise, if it's division, we pop the last 2 values off the stack and then we truncate the division between value 2, value 1. If it's multiplication, we multiply the 2 values and add them back onto the stack. And if it's subtraction, we do the same thing, subtract value 1 by value 2, and then append it onto the stack. So the way this pretty much works is I'm just going to go over this first test case really quickly, just because I think it will give a better understanding of my solution. But anyways, so the first token is a 2. So we see that it's not any of these operands. So we just append it onto the stack or push it onto the stack. Next, we have a 1. So we do the same thing. But now we reach our very first operand, which is a plus. So what we want to do is pop 2 values off the stack. So we have value 1 and value 2. We'll start out with value 1. Just getting a little confused there. But anyways, value 1 is going to be 1. Value 2 is going to be 2. And then we want to append value 1 plus value 2. So since we pop these out, we're going to remove them. And then we're going to append 2 plus 1, which is 3. So we finished the addition token. So now we're at 3. So we want to push 3 onto the stack. And then next, we have a multiplication operand. So what we're going to do is pop the 2 values off the stack. So we pop the 2 3s. And then we want to append value 1 times value 2. So that would be 9. And then now we have no more tokens to go through. So we just pop whatever the last value is in the stack and we output that. So yeah, that's the general idea of, or I guess that's pretty much how the algorithm works. I mean, I think this is a pretty fairly straightforward problem. As for time complexity, it's going to be linear time. And the reason why is because we processed each token only once. And as for space complexity, I mean, it's going to be O of n2 just because at most you're just storing n elements. So yeah, that's my solution for the day.